Okay, so for the next part, it's called summation, and we're finally going to take everything we've been doing, instead of just having a list of numbers. What's going to happen is we're going to start adding up all those numbers in the list. So you could take any of the answers that you just had that had like, 1, 3, 7, 15, and start asking, well, how do we add those all up and find the summation of them? And this little problem here is a good demonstration that, and there's very similar problems to this as well, that if you start one day with like 1 grain of rice, and then second day you double that, and the third day you double that, fourth day you double that, fifth day you double the previous one, right? So the question that you're going to be asking here is, well, what, not just having all the numbers listed with commas, but what if you added up all together? How many would it be? Okay. In this case, it comes out to 3, 7, 15, 16, 31. Okay. All right, but what if we took this to 10 squares or 100 squares, or eventually what you do in calculus, you start adding things up to infinity and start asking yourself, well, what happens if we just go all the way, and how big does it get, or how small does it get, right? So that's kind of where all this stuff is leading. It starts getting us to think about real big numbers and what happens when we get there. Okay, so what I just did is take a partial sum, because if we read this problem, it says a chessboard contains 64 squares, right? We just added up the first 5. So it's not the whole 64, so it's part of the 64. Therefore, it's called a partial sum, right? And we're going to rewrite these things in a certain way. That's just a little new symbol, but keep in mind all you're doing is just a fancy way of writing how do you add up a bunch of numbers. There is a different term that used to multiply a bunch of numbers, but we'll get to that later. So what we're going to introduce here is something called sigma notation, using the Greek letter sigma. All right, which is right here. That's the Greek letter sigma. Okay, and all that means is to add up a bunch of numbers. So we could write this as an a to the n, and I could tell you, find the first 5 numbers, right? So if I could rewrite this problem like this. A to the n equals, 2 n minus 1, like that. And I could tell you what the first term is, and you could just plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, get all those numbers just like you did on your previous homeworks, and then add them all up. That's what this symbol and that's what this whole thing means. It's just, a new way of looking at it, a new way of writing it, but what you're actually doing mathematically is very basic. So again, all this means is that you're going to start with this term, and that's going to be your first number that you plug into here, and you're going to end with this number. So this means we're going to plug in 1, 2, 3, 4, and 5 separately into this, get all 5 numbers, and then add them all up. Okay? So in other words, it looks like this. Okay? We'll have 2 to the 1 minus 1 plus 2 to the 2 minus 1 plus, and then 2 to the 3 minus 1 plus 2 to the 4 minus 1 plus 2 to the 5 minus 1, and stop. So again, this number down here, this k equals 1, is just where do we start. And we got the number on the top here. That tells us, okay, as soon as you get to there, you stop, and you just add up everything in between. Right? So mathematically, what is this? It's pre-algebra. 2 to the 1 minus 1. Right? That equals 1. And then 2 to the 2 minus 1. Right? That equals 3. And so on. So you just keep that going. 2 to the 4, 16. 16 minus 1 is 15. 2 to the 5 is 32. 32 minus 1 is 31. And at the very end, you add them all up. Right? That's what the sigma symbol has us do, is you're adding all these terms up. Instead of just having commas between them like we did yesterday, we now have addition signs between them. Okay? So if we add this up, we got 4, 11, 26, 7, 57. Right? So our answer is just a number. Right? Answer is a number. Okay? So just getting used to how to write this new symbol and how to use this. We can get these. This could be arithmetic. It could be a geometric. As you can see here, this is has a exponential to it, has a power to it, like some of your questions on your homework you're just working on. You had to do like powers of 2. But all in all, not too bad, right? You'll notice the variable could change, so the variable in the expression will match whatever variable's down here, right? So if this was an n and this said j, it wouldn't make sense because you can't plug in n when there's a j, right? So these will match. So once again, it's just going to be 5 times 1 plus 1, and repeat. So, as I mentioned, this is actually a little bit easier than the last section. You just have to be careful with your basic arithmetic. All right. And 16, yes. Next will be 21. All right. And you add all those together. That's 50, 7, 8, 4. Yeah. So that's arithmetic. B is geometric. You can see that, well, since this has a +1 right here, you can kind of tell that, okay, I'm going to be, and multiplying has a little multiplying as well, but this has the exponentials as a variable in 2 places, so you have to plug in the number 2 places. Note that it starts with 3, though. It doesn't start with 1. So there's no rule that says it has to start with 1. Often it does, but it doesn't have to. Okay? So that just equals 3, -1, 3. And then my next number would be 4, right? So then I'll go 4, -1 to the 4th. Next would be 5, -1 to the 5th. And I'm stopping there because that's the last number. So here's where you can start seeing why I wanted you to show your work on all of them, because we start doing this, like, it's not something you want to try to do in your head. You miss one negative, the whole thing is wrong. So if you end up missing these, often it's just because you're trying to not write work down. You're thinking this is too simple to mess up, and that's when it's messed up. So do yourself a favor, spend the extra 3 seconds of your life writing out the work so you get 100% on problems, as opposed to, I'm going to take shortcuts and get everything wrong. Like, there's no point to being first place to the wrong answer. Right? No prize for that. So we got -1 to the 3, of course, is -1. Any odd power will keep it negative, right? So these will keep it -1. The even power will make it a +1, so we end up with a -3, a +4, yeah, and a -5. Which, of course, equals, let's see here, 1 minus 5, which is -4. There we go. All right, go ahead and do 1. Try that out. See how that goes. If it was working for you. And you'll notice how I write my work down just to keep things organized. It might be useful to you, but I like to keep these plus signs lined up. So if I need to check my work, I know where did I get this answer from. I came from this right above it, and I'm not trying to locate where different things came from. So how you write your work does make a difference. when you're doing the checking. Okay? So give that a try. See if it works for you. Alright, ready? Okay, let's keep going to the back. Last part. Let's write some of these in Sigma notation. You guys good? So last part, let's go through and write these out. So these are just those A to the N general terms, right? So you're going to use try to figure out what goes here, use the A plus 1, N minus 1D, or the geometric A1 R to the N minus 1, and simplify it all the way. And that's what's going to go here. Okay? And we just have to make sure we have the right number of terms, so we're going to start at 1 for all these. So for this one, we know already, since I have 5 terms, all right, I'm going to use N. I'm going to start at 1, and I know I'm going to stop when I get to 5. All right, so you can decode that pretty quickly. All right, then we just really have to do what you did in your homework last night, find out what that expression is, and we're good to go. So go through and ask yourself, is it arithmetic? Is it geometric? Find the formula, and just write that right there, and we'll be good to go. So how do we get from 81 to 27? 27 to 9, 9 to 3, and 3 to 1. It has to be the same rule. You tell me. Multiply by 1/3, which is the same as dividing by 3. So if you're thinking, oh, dividing by 3, that's the same as multiplying by 1/3, right? Okay. So we have our R here. So we have our R, which is 1/3, right? We have our A1, which is 81. A1 is 81, right? So as long as you remember your formula, is this, we're just plugging in that information. So we got 81 times 1/3. And then we have N minus 1. Okay. And then you can always check it. You could plug it back in, and you can see, I plug in 1, I end up with 81, I plug in 2, right? So on and so forth. Alright. And you might have to practice doing these little sigmas. Get a little straighter. Mine's a little crooked. There we go. There we go. This button might be on some people's calculators. Some of the more advanced ones, the graphing calculators, do have a sigma where you'd punch in this whole formula. You'd probably use x for the variable, and you put in the lower number and the higher number, and actually does the whole summation. Okay. So this doesn't actually ask us to add them up, so we're just done when we get to this point. Okay. All right, go ahead and get number 2 a shot. This looks like to be an arithmetic one. Yeah. So try that out, see how it goes. One. These ones are a little more difficult, so you can't just go straight for the arithmetic or straight for the geometric, right? It's going to take a little more of that creativeness of just looking for a pattern. Okay? So what is a good strategy is to figure out what's changing and what's not. So you saw one of these, or maybe a couple of these on your homeworks already, where you look at it and you say, well, I know the 5's not changing, so the top's going to be 5. So instead of finding a pattern with the whole fraction, just ask yourself, like if this is the first term, and this is the second term, and this is the third term, we'll pretty much ignore the 5's at this point and just ask yourself, well, is there a property that gives me from 1 to 6, 2 to 7, 3 to 8, right? And if you can find a single way of, single addition or multiplication, then that's going to be your rule for the bottom, and it's just going to have the 5 on top, right? So, anybody see what it is? Yep. Not plus 1, but plus 5, yeah. Because we have plus 5, to get from the 1, I have to plug in 1, I need to get 6. I have to plug in 2, and I need to get 7. So I have to add 5 to each of these, right? And that'll give me the next term. Okay? So you can see it's arithmetic if I just ignore the top and I look at the denominators only. Right? So that's one little method that works really well. So we have just 3 terms. So 1, 2, 3. So I'm going to stop at 3, start at 1. There you go. And that's it. Now that makes it look really easy. I know you can spend a lot of time looking at these and trying to get them and figuring out, but sometimes just go simple at it and it might come to you a little bit easier. Question? Yep?
Would it be wrong if you did 5 over n plus 1, and then you start with the top number, you put 8, and the bottom number, you put n equals 50?
Whoa, say that again?
So bottom number for the n equals, do n equals 6, and then for the top one, you're going to do 8, and then for that, it'd just be 5. 5 over n plus 1.
Let's see here. If you plug in 6, you'll get 7 on the bottom first. So yeah, you start this on 5 and this on 7.
Yeah.
Yep, that would work. That would work. Good job. Okay, right down to the wire.